kind of BDS, and then the BDS variables as well as some assumptions. Okay, we have discussed in detail about the BDS. So now still there are few variables left in the BDS. Okay, so yesterday we start. I mean we stop. The before D type. Okay, so now today we are going to discuss in the D type. Okay, so the basically the D type is nothing but a derivation type. Okay, so as you know in Adam level, okay, we are going to derive the many variables and the many parameters based on the study requirement, based on the SAP, based on the TLF requirement. Okay, this is the variable whenever we created the parameters, or we created any new variables, or we created any particular data points. Okay, so in the D type variable will explain us that what is the derivation type. Okay, so the basically the D type is that most probably in the BDS dataset, wherever we created any additional, we created the results, or we created any parameters. The parameter is nothing but new parameter. Okay, so the test cd here we can call it as a param cd, right? The parameter. So those cases, how this parameter was created, how this was derived, so the derivation type will explain the D type variable. Okay, if you can see the description, variable to be done, how the record has been derived. Okay, so it is required when the analysis value has been imputed or derived differently to the other analysis values within the parameter. Okay, so the basically what I said, when we have derived any particular record or result, so we have imputed the particular result or derived the result, so then how we did that derivation, that is okay, that we can put it into the D type. So for example, here we have the few derivative D types. Okay, LOCF, WCF, average. Okay, so the LOCF is nothing but the last observation carried forward. Okay, so the last observation carried forward is nothing but, okay, for example, if the subject will have the 10 records. Okay, in the 10 records, okay, there are one or two records result is missing. Then this, if in the SAP mentioned that if the results is missing, then you can use for this parameter to derive, or you can use to input these results by using LOCF. Okay, so in that case we are going to use the LOCF. LOCF is nothing but the last observation carried forward. For example, if the current record result is missing, then the same subject, the same test, the previous result we are going to impute to the next result wherever it is missing. That we can call it as the last observation carried forward. Okay, so we'll see in the next slide. Okay, so the WCF is nothing but the worst observation carried forward. Worst observation is nothing but, so what is the worst definition that will be mentioned in the SAP? Okay, it is abnormal or itself, yes, or whatever it may be. So the definition will mention in the SAP. Based on that, if the, okay, if any result is missing, then we are going to input with the worst case. So the average, for example, if any particular record or result is missing, then okay, we can take the previous record average. Okay, then that can, in that case, the D type would be the average. Okay, so the basically the D type variable contains sorry, the derivation type, the derivation, how this the record was derived. Okay, so is that clear for everyone? Okay, so now we'll see the next one. Okay, so if you can see here is that, okay, analysis decision variables. Okay, so basically if you can see these set of records, okay, this set of record is the peak over 3 hours FEV1, and this is the parameter, so the peak over 3 hours. Okay, so the parameter is derived. If you can see the param type, it is mentioned as a derived. Okay, so whereas if you can see the D type is mentioned as the LOCF. Okay, so this parameter is derived parameter, and then the D type is the derivation type is the LOCF. So the how does this LOCF is derived? For example, if you can see the last two records. Okay, so the last two records, okay, if you can see this, okay, these dates are missing, whereas, okay, here the results also is missing, but what we did, the previous record results is, okay, for example, because 1.030605197, this is the result, whereas previously these two records are missing. So that previous value we have imputed to this record and this record. How we did? LOCF, last observation carry forward. Means this is the last observation, then that will carry forward to the next and next. Okay, that's why we can say that. Okay. So now, okay. So and also this is the derived parameter. How it be derived? If you can see this, okay, this is week 2, week 1, day 1. So these three results, if you can see, this is the derived. So the okay, peak over 3 hours. Okay. So then the third and fourth is this LOCF based on the last observation carry forward. Okay. So this one. Is that clear? You have any question in this slide?
Clear, sir.
Great. Yeah. So apart from this, okay, and then Adam BDS variable is the parameter criterion flags. Okay. So there will be criterion flags. The criterion flags is completely depend on the trial specific. Okay. So the trial specific means your trial requires that. For example, any criterion. For example, there will be a table requirement. Okay, the BMI greater than 30. For those subjects only we need to create the particular table. So I just given one example. Likewise, there will be n number of criteria will be required in the clinical trial. So those criteria we can create a criterion flag. Okay. So the, for example, CRITY. Okay. So this Y stands for 1, 2, 3, 4. How many criteria you require? The criterion 1, CRIT1, CRIT2, CRIT3 criterion flags. Okay. So this is the criteria and then criterion flag. This requirement. Okay. If it's yes or no, this is the criterion flag. The criterion flag FN, it's a numeric version. Okay. This okay, 0 and 1 or 1 or 2, whatever it may be. And then this MCRIT, the text string describes the analysis creation with the parameter where the criterion have the multiple responses. This variable required for the multiple criterion exists. Okay. So then the multiple criteria is exist. Based on the multiple criteria, it is created. Then MCRIT. Okay, multiple. So again, it would be the MCRIT 01 ML. Okay. So and then MN. Okay. So the basically this would be the flags, okay, multiple criterion flags and then numeric values. Okay, as I said, each and every variable, most of the cases we will have the numeric variable in the analysis data sets. Okay, but remember when it comes to the BDS data sets, so most commonly we can create a criterion flags when it comes to the Adam. It depends on the trial. Okay, so it's nothing but your analysis requires some criteria. Based on the SAP and the TLF shells, we are going to create those criteria and the criterion flags. Is that clear? You have any questions so far? Okay. So I can take it as no. Then the next, okay, is that okay, the toxicity grades. Okay. So there are some particular tests and test series. Okay, in the laboratory. Okay, some of the lab tests will have the toxicity grades. Okay, based on that, if there are any toxic grade, based on the available is nothing but the results, so core or yes, right? So we can create the toxicity grades. Okay, the ATOXZR. Okay. And then ANRIND, so the reference range indicator. Okay, this is nothing but okay. If you remember in SDTM level, we have the NRIND, LBNRIND. If you remember, biological reference range, high and low, abnormal, normal, those things. Okay, here it is the same variable. It's a ANRIND. Okay. So and then for the particular, if you remember any particular test, we have the biological preference range. Okay, so NRHO, NRHI, NRLO, NR. Okay, if you remember the standard original result. So likewise, this is the variables ANRLO, normal range limit, and then ANRHI, normal range upper limit, lower limits. Okay. So these are the biological. If you can see this SDTM.XX NRLO, NRHI, NRIND. These are the origin for these variables. So the AYLO, analysis range, lower limit analysis range other than the normal range. Okay. So basically this is analysis range. Okay. Other than the normal range. Okay. This will be derived in the BDS data set. Okay. Here is the upper range. Okay. We can derive this, the upper range and lower range, and then again here the analysis range where the Y indicator, the wherever else is falls within the respective analysis range Y. So this range will be mentioned in the study specifically in the SAP. So based on that, we can create this range high and low and indicator values as well. Okay, is that clear? Yeah. So if you can see here, okay, in this example, okay, the above ADLB, we can see how the subject is lactate dehydrogenase prior to treatment were 271 U by L, higher than the upper normal range 250. Thus, the ANR-ND, VNR-ND are the high. So if you can see this, okay, this would be the result of the 271, but actual range is the 250. So that's why it's a high to normal R. Okay, so that would be the value. If you can see this, this would be the VNR-ND high, and then the okay, the high to normal is the later it shifted to normal. For example, then the rare visit 6 value is the 299, which is normal range. Okay, so if you can see the previously the 271, actually the range would be the 250. So that's why it would be high. And then 229, okay, this ANR-ND will be normal, and then the high to normal, that's why. Okay, so the basically these biological reference range indicators will work like this. Okay, so is that clear in this slide? Do you have any questions? Okay, no questions. Yeah, so now here is the BDS variables, indicator variables. Okay, so along with the criterion flags, we can create the ANL01FL. Okay, analysis related flags. Okay, analysis flags. Okay, there the criterion flags, here it is the analysis flags. Okay, so this ZZ would be the 01 to 99. Okay, these many variables we can create ANL01 FL, ANL02 FL, ANL03 FL, like that. Okay, again this would be the analysis requirement flags. Okay, so the ANL XX is also is nothing but okay numeric version of this particular things. Okay, and then ONTRTFL is the flag indicator that observed occurred while the subject was on study treatment. Okay, so this flag will be created, the subject is during on the treatment. Okay, on treatment flags. Okay, so the whether subject is on treatment flag, yes or no. So the on treatment flag numeric version. Okay, so then the LVOTFL, LVOTFN, which is nothing but flag indication observation is subject to last non-missing value while the treatment for the parameter. Okay, so what was the last non-missing result for the while the subject is on treatment? Okay, so why during the treatment phase, what is the last non-missing value? That would be the LVOTFL value. Okay, so these are the study specific. Okay, if we really required, we can create. Otherwise, it should be fine. Okay. So as I said previously, in the Adam level, there are the many variables, okay, which will not needed for each and every trial, and then there are some other variables we can create by our own, okay. So it will not everything will be mentioned in the Adam's SG, sorry, Adam IG. So whereas in SDTM it's not the case. SDTM is a standard. What are the variables you will have? That only you should create. You don't have any permission to create your own variables. Okay. If there are anything which you want to create, that values should be going to the supplementary data set. There we can create a QNAMs. But in whereas in the Adam it's not the case. Okay. So within the this Adam IG rules, you can create the study specific requirement variables. Okay. So the next, okay, so for what we discussed the each and every variable about in the BDS structure, how it looks like, and okay, BDS dataset. Now we can see the BDS structure. Okay, so what is the BDS structure? Okay, so if you can see this analysis variable is nothing but eval and eval c. It's a result. Okay, so these variable will be depend on all these things. Okay, so why we can say this analysis variable is eval c? Obviously in the test CD result, what is the important thing? Obviously result, right? So that's why it should be the ORRES and SDTM level. Here is the eval c is that. Okay, so for example, what kind of variables we have seen? So for the identifier, study ID, subject ID, use subject ID, and the sequence, these are all the identifiers. The treatment related variables, we have seen the TRTP and TRTPA. TRTA, planned and the actual treatment. Okay, the dose variables also we have seen, the dose, actual dose planned. Okay, the timing variable we have seen, the timing variable is ATPT, A phase, A visit, ADT, ADY. So A stands for the analysis, if you remember. Okay, so these all are the timing variable we have seen most commonly. And the parameter variables, the param CD, param and the param, which is nothing but a test CD and test. Okay, here is the param is the numeric version of your parameter. Analysis variable is nothing but the base change, percentage change from baseline and the base type. Okay, these are the dependence on the your baseline flag related. Okay, what is the base value? What is the change value? Change is nothing but base minus, okay, your eval. So the percentage change minus is nothing but the base minus evals divided by the base minus evals into base. So that will comes to here your percentage change. Okay, base type, what would be the base type? Baseline flag, if derivation is that, okay, last non-missing value, you can put the last, and then otherwise based on the what we have derived its average or whatever the value, that can put in the base type. And then time to event variables, it is nothing but event description is nothing but event DES, event description, and STAR, TDT, and then sensor variables. Okay, start date of this one event, and then the sensor. CNSR is nothing but sensor. This will be the time to event data set. Okay, ADTT example. The descriptor variables, so D type and then A range. Okay, AW range. Okay, we have see the D type, right? What is the derivation type and the range all. Toxicity grade variables is a toxic, okay, ATOXER and then ANRIND. These are the biological reference range indicator, as well as in LB there will be some toxic range. Okay, the indicator variables on the ABLFL, NL01FL on treatment flag. Okay, so these are the baseline flags and the analysis flags and the on treatment flags. If you can see that in BDS, these kind of, there will be almost, okay, 10 to 12 types of 10 to 11 types of variables we have in the BDS level. Okay, identifiers, treatment variables, dose variables, timing variables, parameter variables, analysis variables, time to event description variables. Okay, and then the describe variable, descriptor variables, and then toxicity variables, and then indicator variables. So these are the variables we have discussed so far in the BDS. Okay, so that's it about the BDS. Okay, is there any questions from anyone? So if you have any general question also, you can ask me, still some time available. Okay, so anyway, I'm not going to start the occurrence data structure now. We'll take it tomorrow, occurrence data structure. So for now, we can take up the questions, any in general question, or in the today's session, previous session, SDTM, or anything. You have any common question also, you can ask me, since we have the time. Okay. Indicator, when we discussed day before yesterday, right? Yesterday.
No, this one only. Today's only. Before the analysis variable, we did indicator. Today's class only.
Mm-hmm. Mm-hmm.
ANL, XXFL.
Yeah. Got it. Yeah, this one.
Yeah, this one. Thank you. I just wanted to read this last line.
What is the question?
Not questions. I had missed reading the last two, so I wanted to just read it.
Okay, so is there any other questions from anyone? part.